Hi, my name is Maynard King. I'm with King Process Technology, and we installed the water treatment system here at Cache River. I'm going to go over the water treatment system and explain what everything does, and I'm also going to point out some troubleshooting hints and things like that. So what we have here, an overall view, is water is coming in from the well, and it's coming up through the floor. And it's coming in through this blue valve here. This blue valve, the normal position of this blue valve is the on position. And water comes down through that and in through the tank. But just before, as soon as it comes out of the floor, if you look at the black thing back there with this tube hooked up to it, we're injecting chlorine into the water. And the chlorine is basically just a mixture of Javex and water. And the job of the chlorine is to precipitate out iron and manganese, which you have a lot of metals in your water. So the chlorine hits it, and then it goes into this tank. The purpose of this tank is basically to slow down the water and give the chlorine some time to react. So the water comes in, it's only moving at about 3 gallons per minute, because that's what the system draws. And as it comes in, it slowly moves up in this tank. That gives the chlorine about 20 minutes, 25 minutes to react with the metals and precipitate out down to the bottom. So what happens is you get like a bit of a sludge at the bottom of this tank. After the water comes out of this tank, it goes through this valve, which is the normal operating position is on, and then turns left to go to the filters. I also want to point out this valve here. This valve is actually a bypass valve, so that if you wanted to take this tank completely out of service, all you have to do is close this one and open that one, and the tank will be bypassed. And you can also close that blue valve down below, and now the tank is not pressurized anymore at all. So by closing the inlet to the tank, the outlet to the tank, and opening this bypass, the water is not going through this pressure tank. And it's not the same as a pressure tank in a well. There's no bladder in it or anything like that. It's an empty tank, except for it's got baffles to help the water mix as it goes through. About once every 3 weeks to once a month, you should purge this tank, because as the chlorine reacts with the metals, it precipitates out this dirty, rusty sludge, which falls to the bottom of this tank. And eventually you'll probably get 2 inches of sludge in the bottom of the tank. So on the bottom of this tank, there's a blowdown valve. And a blowdown valve is basically a valve that you can open to purge out sediment. So all you do is you open this valve like that, but you leave it open for about 30 seconds or around 20 seconds is plenty. That valve basically goes right to drain, and the pressurized water is still coming in, and so what that does is blow the sediment out of the bottom of the tank. Do that about once a month. So after the water, which now has been chlorinated, comes out of this tank, it first goes into this filter. Both of these pieces of equipment, by the way, are Culligan filters. They're exactly the same, except for the first one has a different media in it than the second one. The first one is basically filled with a sand media, various grades of sand, going from coarse at the top to finer in the middle to finest down below. And it's got sand, anthracite, and garnet, and basically it's a filter. So what that does is filter out any of the rusty sediment that didn't settle out in the big tank. It gets filtered in through this tank. And so it basically filters the water to around 15 micron. And to give you an idea how small that is, the cross section of a human hair is 70 micron. So the sand will filter it out, and the dirt will get caught all down through the media. Now, once in a while, this one will backwash. And it backwashes using the line pressure coming from the well. And when it backwashes, it'll happen at like 2 o'clock in the morning, and you might hear a hissing sound. And that's just this filter backwashing. And when it backwashes, it mixes the media all up and throws all the dirt out, and the dirt goes out through this black hose right here down to the drain. So if you hear a hissing sound at 2 a.m., chances are that's not a leak, that's just the filter backwashing. After it leaves the first filter, it goes into the second one. So the second one is exact same equipment, except for it's filled with granular activated carbon. It's basically charcoal that is crushed up, and it's the same stuff as you find in a Brita filter that you get in your fridge, but quite a bit of it. There's like 1.5 cubic feet of it in here. And the job of this filter is actually to remove the chlorine that we put in the first step, because the membrane system cannot handle the chlorinated water. So the carbon, it does filter the water nicely as well, but the most important job this does is to remove the chlorine again. This one will backwash a little bit less often, maybe once a month at the most. And when it backwashes, same thing happens at like 2:30 in the morning, and makes a hissing sound. Takes about 22 minutes, either of them, to backwash. All right, after it leaves the carbon filter, now we inject another chemical, and this one is antiscalant. And the job of the antiscalant is to keep the different salts and metals and scale from forming on the membrane system. So it's basically a food safe chemical that is keeps the scaling from forming on the membranes. After we inject the antiscalant, it goes through a pre-filter. In this should be a 5 micron filter, and that's basically one of these right here. It's a 5 micron filter, and it needs to be changed once in a while, and I'll talk about that in a minute. To change that filter, there's a wrench here that you put on the bottom of the blue thing. It only fits up about that far, but then you can twist it and undo that. It's basically, this is threaded onto the black piece. But before you change it, of course, what you need to do is release the pressure that's in it. So to change the filter, you shut off this valve, you shut off this valve, that's the inlet and outlet, and now there's a red button right up there on the top. You press that red button and water's going to squirt out, but the important thing you're doing there is you're releasing the pressure. And that makes it a lot easier to take this off and make sure you don't get so much water spraying out at you. So close inlet and outlet, press the red button until the water stops coming out. And it's very difficult not to spill water. So I recommend you stand on a chair and get this thing and put underneath like that, and then unscrew the filter and try to catch it when it comes off, and it's going to be filled with dirty water. So you want to try to hold on to that and move all of this together. And now bring this, and you can empty the water in the toilet, empty that out in the toilet, and the filter can go in the garbage, and you pop your new filter in. When you put in the new filter, the yellow, just on this brand anyway, has to be on top. And you can see that because the bottom has like an indent, but it's plugged. So this one, the yellow faces up, it sits in the blue housing, and then you just screw it back on. The way the blue housing seals to the black part, the top, is there's a large O-ring there. Make sure that that O-ring is in place nicely so that when you screw it back on, you don't get any leaks. After it goes through the inlet filter, which filters it to 5 micron, it basically is going to this skid. So this is a reverse osmosis skid, and it's got 3 membranes, and it's basically, the reason why it has so many membranes is because it's very difficult to filter out the salt that is in your water. You've got basically seawater coming out of your well. It's so high in salt that it's pretty well seawater. So what a reverse osmosis membrane actually does, it's so fine that it actually filters out salt molecules. So going into the filter is salt water, coming out is fresh water. And it will remove pretty well 90% of the salt that's in the water, leaving only a tiny amount left over. The way the system works then, after this system, which is loud when it's running, because it has a very high horsepower, very high pressure pump, so it's nice and loud. So as it's running, the product water, which we call permeate, comes out of this tube and goes into the large tank. While it's running, it also sends a constant waste stream. So coming out of this tube, the one that goes horizontally, basically that tube goes to drain. So while it's running, it only makes around 0.25 gallons per minute of good water, and it's throwing out around 2 gallons a minute of wastewater. So these things are water hogs. They waste a lot of water, but it's the only way to get salt out of water except for evaporation. So if we didn't have such a high waste stream going to drain, the salt will basically build up on these membranes and clog them. So it's important that the waste stream is always going to make the product water. So basically, we're only making 0.25 gallons per minute, which is a very small flow. When you think that a tap has around 5 gallons a minute that can come out of it. So it's important that we have a lot of water storage, and that's what this tank is. This tank contains 600 liters, that's like 225 imperial gallons, 270 US gallons in it. So it's a fairly heavy tank. And what we do is there's a level switch way up on the top. If you look way up on the top, you can see a gray piece of 1/2-inch Schedule 80 pipe. On the end of that pipe, only about 8 inches down, is a little float. It's a single level switch. So that level switch, as soon as it drops, the system will start up. So it won't wait till the tank is half empty. As soon as that level switch on the top drops, the system will kick in and it'll start making water. Why? Because it takes a couple of hours to make this much water in the tank. So it's important that we have a lot of water storage. So if you use a lot of water at this facility, you could empty the tank halfway down within, if 3 guys get a shower and someone does laundry, the tank might be half empty. But then it'll take a few hours to fill it back up until it's full again. So that's why we have so much water storage. So the finished water in the tank, just focusing on the tank for a second again, there's just this filter here, which is just an air filter. There's nothing that you got to worry about that. And then we have an overflow put on this tank as well, so that if the level switch fails and the system keeps making water, the overflow will just go out there and down into the basement. So we got the overflow so that if the system overflows, you don't get a puddle of water here on the floor. So this pump draws the finished water then from the finished water tank. So its job is to take water from this connection down here, right at the bottom, through this 1-inch valve, through this 1-inch hose, and send it to the facility. So it's an automatic pump that you don't need to do much with. You can turn the pressure up by hitting this up arrow right here, and you can turn the pressure down by hitting this down arrow. There is a start and stop on the pump, so if I hit that, the word stop comes up here. So if you see that word stop, the pump is not running, and if you turn on a tap, pressure will just drop and no water will flow. So if you do ever open the tap and no water's coming out, you might want to check there first to see if the word stop is there, or to see if the pump is unplugged or something like that. It's just a 110-volt pump that's plugged into a receptacle. So to start the pump again, you just hit the power button again. The word stop goes away. So the pump runs on demand. Basically, when someone turns on a tap, there's only a tiny little pressure tank up there on the wall that only stores about 1 gallon. And once about 1 gallon comes out, this pump will kick in. And it's called a constant pressure pump, which means it'll run to maintain pressure to your system. So it doesn't turn on for 5 minutes and stop, and then you keep running water. As long as you're running water, the pump will probably kick in and out and maintain a constant steady pressure to the tap. That's what we call a constant pressure pump. The pump is a self-priming pump. So like any self-priming pump, if you ever have the system drained and you need to start it up again, it's very important that you prime the system. There's a plug here for priming that you take out and fill it. But I should note that if the tank is filled with water already, permeate water, all you really need to do is loosen this plug, and the head pressure in the tank will flow through the hose, work its way up the pump, and it would actually overflow here if you don't close the plug quickly. So it's an easy system to prime because it's got some head pressure. Other than that, it goes right to your system, and that's it. So that's the layout of the system here in Cache River. Now, I want to talk a bit about the reverse osmosis skid. So when this skid is running, it sounds like a compressor. It's a pretty loud system. It's because it's got a kind of a hydraulic type pump, a piston type pump, which makes a lot of noise when it runs. So it's recommended to keep that door closed so you can sleep if it's running. There's a control panel that governs the whole system. So basically when the system runs, we have a bunch of gauges here that will read pressures. The first one is the pre-filter inlet pressure. That is the pressure coming into the blue filter up top. And the second one is pre-filter outlet pressure. And that one is the pressure coming out of that filter. So remember earlier I talked about the 5 micron filter that goes in the blue housing. If you see a large difference between these two, that's a pressure drop. That means that this filter up there is plugged and it needs to be changed. So the pressure will normally fluctuate up and down between like 20 and 40, and all that is the well pump kicking in and out. But the important point to note is if you see 30 on the inlet, but you only see 20 on the outlet, that's a pressure drop. That means your filter is probably plugged. But if that filter is plugged, you'll probably get an error anyway. Down on this control panel, there is a red alarm called low inlet pressure. So if this one comes on, it means that there's not enough water supply coming to the system. So either somebody turned off a valve, or the well pump is down, or that filter up there is plugged. So if you see this red light, you need to rectify why is there not enough water pressure coming into the system. And then once you've got that rectified, you can reset the alarm right here. There's a reset button. So that goes for any of the alarms, by the way. There's a reset button for most of the alarms that you would see, except for RO pump motor fault. So just back to when the system is running. So when it's running, you will notice these two pressures here. The membrane feed pressure is the pressure coming out of the high pressure pump. For Cache River, that runs at about 800 to 900 psi, and that's because you have pretty well seawater coming out of this well, so it takes a lot of pressure to put it through the membranes. And to give you an idea, your normal pressure in a house is 40 to 60 psi. So we had to actually pump that water to 900 to push it through these membranes to get fresh water out. The concentrate pressure, that's basically a back pressure that we put on the drain that I was talking about earlier. And so you'll see that this one is a little bit lower. So this one might be around 700 to 800, while the membrane is 800 to 900. So if you see the membrane pressure going to 1,000 or so, you might want to back off the pressure. And the only control that you have on the whole system is this one valve. It's a needle valve, and it's called the concentrate recycle valve. Basically, the more I close this valve, I'm pinching off the drain, which puts more of the pressure to the system. So both gauges will go higher when I close this valve. Both of these gauges will go lower when I open this valve. And also you'll see the flows change. So what is important for you to do is to keep the membrane pressure below 1,000. If it's approaching 1,000, back this off a little bit. And the other thing is you'll see your concentrate flow and permeate flow. So basically there are two flows for the system. One is the amount of water that we're making. This one called permeate is the product water. It's the water going to the storage tank. This one will normally run around 0.25, which is right here. So on the left side, you'll see 0.1, 0.2, 0.3. So only around 0.25 gallons per minute right there is where this float will be. And you read the float at the largest part. So if I close this valve and put more pressure to the system, this will climb. And you can't really operate at around 0.4. If you do, the pump will trip and things like that. You really need to be between 0.25 and 0.3, and if you find if the system is tripping out at you, just keep it at 0.25 gallons per minute. So you'll notice that the concentrate flow, this is basically our waste that we're putting out. I told you that we're wasting a lot of water as we make good water. So this one normally runs at around 2 gallons per minute. And you read this one at the top of the float. So the top of the float will be around 2 or a little bit lower. And you'll see that the more I close this valve and put more pressure to the system, this one will drop a little bit, but not a lot. Normally it stays around 2 gallons per minute. So the important things for you to look at when it's running, just to do a check on the system, is what is my permeate flow, which is the water I'm making, and my membrane feed pressure. So adjust this black valve to keep your permeate flow around 0.25 and your membrane feed pressure below 1,000. And you'll notice the gauges move as soon as you start tweaking this valve. And it's not a constant adjustment, it's just an adjustment that you should check on every now and then while it's running. You can only do it while it's running. Check on it to see that those parameters are around there. So let's talk about how the system is turned on and off. It says RO system, hand, off, auto. Basically, the normal operating position of this switch is in the auto position. And when it's in auto, it'll basically follow that level switch that's in the tank. So the level switch drops, it'll automatically kick in. That's why it's called auto. If the level switch crapped out, not working, and water's dropping in the tank and you got no water, you can actually flip this switch over to hand to force the system to run. And it'll run and it'll start making water. However, what you got to remember is that it will also overflow once the tank gets full. So until someone gets a hold of me or the level switch is fixed or replaced, if you run it in hand, make sure you just don't overflow it. You fill the tank up and then turn it to the off position. But turning it to the off position at any time stops the whole system. Nothing will run when it's in the off position on this control system. Normal is auto. When the tank fills, it gets to the full position where the level switch float goes up, and it'll actually run for another 20 minutes after the level switch is up. And at the end of that 20 minutes, it'll do a flush. That's when this light turns orange. And the flush basically takes some good RO water from your taps and floods it through these membranes to get rid of the salt and sediment that might be on the outside. So that flush lasts only a couple of minutes. Once the flush is over, the blue light comes on saying the permeate tank is full. And then it'll stop. And it won't do anything again until water's needed. The other lights that are here, chemical tank empty. If either the Javex or anti-scalant tank goes below the level switch, this will light up. So if you see this light, it means it's time to refill chemical. And I'll talk about the chemical pumps in a minute. This light, pre-treatment lockout, if either of those filters I talked about earlier, the Culligan filters, if either of them goes into a backwash at 2 o'clock in the morning, then the pre-treat lockout light will light up as long as that backwash is occurring, so that the system doesn't try to make water during a backwash because it has no water supply. And the last two lights, RO system run. Whenever the system is running and that loud pump is going, RO system run is lit up. And the last one is RO pump motor fault. Inside this panel, there is an overload relay, and I'm going to show that to you in a minute in another video. If you see this red light lit up, you need to open it up. Let's stop it there for a second. So if you see the RO pump motor fault light up, it means that the pump tripped. And what can cause a pump to trip? If there's way too much head pressure on it. So if you were trying to operate up at like 0.39, 0.40, 0.45 gallons per minute permeate flow, and the pressure was up to 1,000 psi and all that, that might trip out that pump. And that's why it's important to keep her right in the normal operating parameters. So if you see RO pump motor fault lit up, the system will not run until you reset it. So the way you reset it is you need a Phillips screwdriver, and there's screws right here and right here on the panel. There's also screws on this side, but don't do them up because you don't really need them on. The only ones you need to tighten are these and these. So you get a Phillips screwdriver and you undo the screws top and bottom, and now this door swings open. It's perfectly safe for you to open this panel without turning off any breakers. And down in this corner is overload 1, OL1, and this is the contactor that contacts the motor M1. Basically, this overload relay runs our high pressure pump, which is down in the bottom. So if RO pump motor fault is tripped and the red light is showing, all you got to do is open up the thing, and now you can press this right here. So this is basically a button. It's a reset button just for that particular alarm. So when you press that, you'll hear a click, the system will be reset, and that's pretty well it. That's the only thing that you need to do in there. There are circuit breakers in there. I don't recommend that you guys get involved in any of that, but that one there you might have to open up and press if RO pump motor fault comes on. And then you start the system again. When you close the door up, you start the system again, and you can try to see what caused the RO motor to trip. And usually, like I said, what causes it to trip is you've been operating at too high a permeate flow. So the pump is basically working too hard and drawing too much amperage. Other than that, there's some sample valves here that you can get a raw water sample and a permeate sample. And a concentrate sample is basically, this is the waste, this is your product water. So the water coming from here is the water we're making. The raw water, of course, is the water right from the well. Other than that, there's really no maintenance for you guys to do on that system. Membranes will have to be changed eventually, maybe once a year or so. And if they, once they do, we can come in and we can change those for you. Or the good idea is to actually get these cleaned and returned, and have rotate a set that's being sent for cleaning and a set that's in operation. So to change membranes, you just shut the system off, depressurize, and you have to basically take out the fitting nuts and all that. Other than that, last thing to look at here in Cache River is the two chemicals. So we have two different chemicals. Remember, at the very beginning, we're injecting chlorine. So the chlorine tank, I've got a note on the top saying that when the level is down to the black fitting, and that's this fitting right here, basically there's a level switch in there, just a float that drops down when the level goes down to here. So when it gets to there, you basically put in 1 liter of Javex 12, which is this here. It's called Atlantic 12. It's basically 12% Javex. If you can't get 12% Javex, you can use regular household Javex. Then you'd have to use 2 liters because regular household Javex is only 6%. If you do that, make sure you don't get country scent or some kind of fresh scent or anything like that. That will be harmful to you. So only pure Javex, which is perfectly safe. So you put in 1 liter of Javex 12 or 2 liters of household Javex, and then you fill to this mark right here, which is the 10-gallon mark, with water from a tap somewhere. So just use a jug or something, or there's no garden hose, so I guess you can use a bucket, basically a clean bucket, put in your liter of Javex, and then fill the rest up to this mark right here. And here's where you fill it. To undo this cap, you basically have to pinch these 2 little nibs that you see here coming off the cap. You gotta pinch it like that, and now it can be unscrewed like this. So that's where you pour in the Javex. The metering pump itself runs automatically, and it basically clicks. Every time it clicks, it draws a tiny bit of Javex into the head, squirts it out this tube, which goes across the room and over the door, and then goes into our injection point. On the face of this metering pump, there is a little dial, and I've got that dial set down fairly low. It's just a little notch below 1 gallon per day. So when it's running, it's not even using a gallon per day. It's only going to use like a 1/4 of an inch out of this per day. But basically, don't change the position of this dial, because if you turn it up, you'll be putting a lot more chlorine into the system than needed. So just keep it a notch below 1 or around 1, something like that. We've got the exact same chemical system for the anti-scaling. And remember, that's the one that gets injected right before the blue pre-filter. So for the anti-scaling, it's a similar thing, exact same metering pump. This one is a little bit more lower. It's only around 0.5 gallon per day injection. And when this one goes empty down to the black fitting, and how do you know when either one is empty? Remember, this light over here, chemical tank empty, will come on. So you just wait until you see that, and then you know that at least one of your chemical tanks needs to be refilled. So for anti-scalant, when it's down, if that's the one that's down to the float, then you add 200 milliliters of this. This is called PWT SpectraGuard. It's basically a food-safe anti-scalant. And so there's a measuring cup right here. You fill that up to the 200 liter mark, which is 200 milliliter mark right there. And then you fill the rest up to the 15 gallon mark, which is right here on the side. That's 15 gallons. So 200 milliliters in this, pour it in there, and then fill the rest up with water just from the kitchen tap. And then that is it. If there's any questions on the system, please feel free to call me at 709-730-5557 or email me, maynard@kingprocess.com. I can also be found on Facebook, and Facebook it's just Maynard King, and you'll that way you can connect with me here because there's no phone system. Thanks. Hi, Maynard King again. I'm in the basement of Cache River. It's important that I show you the stuff down here as well because there's quite a mess down here. You've had 3 different jobs done over the past few years to try to fix the water. So I wanted to show you how the system works right now, how you can bypass it to go back onto the water from the garage, or even bypass it to go on well water, which I hope you never got to do. So the first thing I'm going to point out is this system right here. This system and the tank behind it is an old reverse osmosis system. I guess it wasn't set up properly or whatever. It was more of an off-the-shelf type system, and that is condemned. So don't use that system. And this is the valve leading to that system. It should be just left shut off. Don't ever use that valve. And unfortunately, whoever installed the system put in this metering pump up here to inject chemical into the stream, but they never put any shut-off valve at all. So hooked up to your well, there's this metering pump, so you can't really rip it out until you shut down all the water, cut this PEX, put on a valve, and shut it off. So if you want to get rid of that equipment, I guess you can do that. So let's talk about the layout of your system. The water coming from the well is actually in this 3/4 copper, heavy copper wall, I guess it is, line. So it's a pretty small line coming in. That is the water coming in from the well, operated by this pressure switch. So this pressure switch kicks in at 20 and kicks out at 40 to maintain pressure in this pressure tank. That's your well tank. Once it comes out of the well through the pressure switch, it goes back here. That's what leads to the pressure tank to maintain pressure. It comes out of this rusty old valve, which is I was afraid to shut off myself. We didn't use it because it looks pretty ratty. I wouldn't even use that unless you have a bad leak and you got to. So forget about this line. That's the old system. Water comes out of the well and goes up through here. Forget about that direction. That's the old system. The water turns left. So this is one shutoff you do have coming from the well. If there's a bad leak somewhere else and the well water is coming out everywhere, you could shut this valve off and you have shut off your water. After it leaves here, this is a connection that we put in. So this blue valve is the feed to the new water treatment system. So this is where we're taking the water. It goes up through there, makes the turn, and goes across the room, and that's where it comes up through the floor and feeds to our pressure new tank, our contact tank that we've got upstairs. So if you have a bad leak and it's somewhere where there's no valve, you can shut off this valve right here, and I've now shut off all the water leading to the new water treatment room. So the normal operating position of this valve is on. The water then comes up here. This T off right here is, remember, this is, so water going to the water treatment system here, but there's still well water coming up here. So this is raw well water coming up, and this is basically the line that feeds your toilet, which is great to have because instead of using expensive reverse osmosis water for your toilet, you're just using the raw well water. That's why the toilet, it's got sediment and rust in it and stuff like that. So if you actually wanted to send the raw well water to the building, this is the valve you would open up. If you open this valve, you would be sending raw water from the well to the whole building. So normal operating position of this one, closed. And finally, before it goes to your distribution system, which is this top T right here, there's another blue valve back here. This blue valve is on the end of a black poly line that leads to the garage, and that is where the emergency temporary water supply is. So basically, if you want it to go back on the garage water, the temporary water system coming from the tote tanks, all you'd have to do is open this valve, and you now have the water supply coming from the garage, as long as the pump, of course, is running in the garage. If you do that, if you want it to go back on the emergency water, just open that valve. And you don't really need to shut off our system, but maybe if the reason that you do have to do that is that the system is, I would recommend you do. So if you do go back on the garage water, open this blue valve, and then shut this blue valve down here that leads to our water treatment system. And that's pretty well all you got to do. Once it's all straightened out and the new system is running again, you open this valve and close this one. Other than that, the piping just goes to your distribution system, to your various kitchen taps. So, any questions, give me a call. Yeah, it's Maynard King. One thing that I forgot to add is that if the system is not making water, so if the level in this tank is dropping and it goes below here and the system is not kicking in and the blue light is still lit up on the system, then there's an issue with the level switch. Basically, it's not getting the signal from that level switch up there on the top. So all you got to do, it is possible that a little bit of shavings from drilling the tank or even a tiny bit of anything catches up on that float. The float doesn't drop once the water level drops. The float kind of hangs up. So all you got to do is get up on a chair or a ladder, not even tall enough for a short guy like me, but that level switch on the back that has the wire sticking out, that's only about this long and it's somewhat flexible. You just grab onto that, give it a shake. When you give it a shake, the level will drop, the blue light should go out, and the system should kick in again. Otherwise, if that doesn't work, give me a call. Thanks again.